Hello, we'll be solving questions from chapters 15.7, the maximum and minimum values of SUPA Maths multivariable calculus. Let's see question number 1. It says, suppose 1, 1 is a critical point of a function f with continuous second derivatives. Now this is important because for second multivariable calculus, we solve relative extrema questions with the second derivative test, and not the first derivative test, so this part is important. And each case, what can we say about f? So this is direct applying of the determinant on that of f of xx, let's use xy here, times f of yy minus f of xy. And the reason why we don't do f of yx also is just simply Clay-Rowe's theorem. So you can technically think of this as like this, but Clay-Rowe's theorem basically says that it's okay to abbreviate like this. Now for this d, we learned last time that if it's bigger than 0 and this is also bigger than 0, then we have a minima. If this is less than 0, then we have a maxima. And if this was less than 0, then it was a saddle. And if it was equal to 0, then we don't know. So let's check for a. 1, 1 is 4, and 1, 1 for yy is 2. And we would divide, subtract xy squared, which is 1 squared, and that will come out to 7. Now the exact value doesn't matter because we know it's bigger than 0, and we know this is bigger than 0, so this is going to be a minimum, relative minimum. Now for b, we know d equals to f of xx is 4 times f of yy is 2 minus f of xy squared, which is going to be negative 1. And so this is less than 0, and so now that we know this is a saddle point. Pretty easy.